Imagine you're standing on solid ground. Now imagine that ground starts to rise, slowly at first, then faster. 1 meter, 10 meters, 30 meters. The rock you're standing on is heaving upward like a slow-motion earthquake, and it won't stop until it's climbed the height of a 30-story building. Then it comes back down, and 42 hours later, it does it again. That is Tuesday on Io. That is every single day on the most violent, most extreme, most genuinely terrifying moon in the entire solar system. This video is about Io, Jupiter's innermost large moon, and why it might be the most alien place we've ever discovered. Now, most people know Io has volcanoes. That's the headline. That's the postcard. But the volcanoes are almost the boring part, because what's actually happening on and around Io is so far beyond what most science content ever covers, that by the time we're done here, you're going to look at this little orange moon completely differently. We're going to cover 10 things about Io that almost nobody talks about. And I'm going to save the most mind-breaking one for last, because it involves Io literally being eaten alive by its own destruction. Let's go. First, you need to understand what's actually causing all of this, because without this, nothing else makes sense. Io sits in a gravitational tug-of-war. Jupiter is pulling on it from one side. 2 other large moons, Europa and Ganymede, are pulling on it from the other. This creates a constant, rhythmic squeezing, like gripping a stress ball over and over, except the stress ball is a moon and the hand is made of planetary gravity. That squeezing generates heat. Enormous, relentless, interior heat. And that heat has to go somewhere. It goes up, in the form of over 400 active volcanoes, in the form of lava lakes, in the form of eruption plumes that shoot 500 kilometers into space. Io doesn't just have volcanic activity. Io is volcanic activity. The entire moon is a heat engine being powered by gravity. But here's where it gets strange. Really strange. Because the ground moving up and down 100 meters, that's not a metaphor. That's measured. NASA confirmed it. Earth's highest ocean tides, the ones in the Bay of Fundy in Canada, reach about 60 feet. And that's water. Liquid. The easiest thing in the universe to push around. On Io, it's solid rock, moving twice that distance, every single orbit. The mechanical flexing from that motion is what keeps Io's interior molten. It's not radioactive decay like on Earth. It's not leftover heat from formation. It's pure mechanical kneading, like a planet-sized microwave running on gravity. And it never turns off, because the orbital resonance with Europa and Ganymede is locked in. Permanent. Io will be squeezed like this until the solar system ends. That's important. But if you don't also understand what Io's mountains actually are, you're missing one of the most counterintuitive facts in all of planetary science. Here's what you'd expect. The most volcanic moon in the solar system should have volcanic mountains. Tall cones built up from lava over millions of years, like Hawaii, like Olympus Mons on Mars. That's not what Io has. Io's mountains have almost nothing to do with volcanoes. They're being squeezed out of the ground from below. Here's what's happening. Lava constantly erupts and buries the surface, layer after layer after layer. That weight builds compression in the crust, and eventually, deep rock gets thrust upward and over shallower rock. Entire mountain blocks punching straight up from below, like squeezing a wet bar of soap until a chunk shoots out of your hand. Some of these mountains are taller than Mount Everest. On the most volcanic body in the solar system, the mountains aren't volcanic. They're being extruded by the weight of lava pressing down from above. The volcanoes and the mountains are essentially fighting each other. The lava tries to bury everything, and the crust fights back by launching mountains skyward. There's nowhere else in the solar system where this happens. But the mountains aren't even the weirdest geological feature on Io. That title belongs to a place called Loki Patera. Loki Patera is a lava lake, not a small one. A lava lake, roughly 200 kilometers across. Its surface area is larger than Lake Ontario. It is the most active volcanic feature in the entire solar system. And it does something that sounds almost mechanical, almost clockwork. Periodically, the crust on top of the lake solidifies. It cools. It gets denser than the magma beneath it. And then it sinks. The whole surface founders, cracks, tilts, and gets swallowed back into the lake. Fresh, glowing, molten rock is exposed, and a wave of this overturning spreads across the lake at about 1 kilometer per day. When this happens, Loki's heat output increases by 10 times. And researchers think it might be predictable, precisely because the lake is so large that basic physics dominate. No chaos, no randomness, just a giant alien lava-filled clock running on a 400 to 600 day cycle. A scheduled apocalypse every year and a half. Now, if you're enjoying this, if ordinary isn't your thing, subscribe for the cool, the unexpected, and the unforgettable things that make you stop scrolling. Subscribe now. But stay here, because what's coming next completely broke the scientific consensus in 2023, and nobody's fully explained it since. For decades, scientists had a problem with Io's volcanoes. They were in the wrong place. Tidal heating models predicted where the hottest zones should be, where the squeezing from Jupiter should be most intense. But when scientists mapped the actual volcano locations, they were shifted 30 to 60 degrees to the east. Consistently, globally, every model was off. The leading explanation was a global subsurface magma ocean, a layer of liquid rock beneath the entire crust, like a planet-wide underground sea. The fluid tides in that ocean would shift the heat pattern eastward. It was elegant, it was testable, and for a while, it was the consensus answer. Then Juno arrived. NASA's Juno spacecraft made close flybys of Io in 2023 and 2024. And what it found dismantled the magma ocean theory. The evidence suggested that Io's volcanoes aren't connected to a shared underground reservoir at all. Each one appears to be powered by its own isolated chamber of roiling magma. Independent systems, not a global network. So now we're left with this. The volcanoes are still in the wrong place. The best explanation is gone. And the mystery is wide open again. On a moon we've been studying for 45 years. We just had to throw out the answer and start over. But here's what Juno did see while it was there. In December 2022, just before the close flybys, something extraordinary happened. Multiple volcanoes on Io erupted simultaneously. Not a normal eruption, an unprecedented event. The eruption covered approximately 40,000 square miles. It released between 140 and 260 terawatts of energy. For comparison, the 1980 eruption of Mount St. Helens, one of the most powerful volcanic events in recorded human history, released about 52 terawatts. This single Io event was 5 times more powerful, and it increased Io's overall brightness by over 1,000 times above normal. 1,000 times. Evidence suggests the eruption didn't just come from one spot. It traveled beneath the surface for hundreds of kilometers before emerging. The entire underground system fired at once, like the moon itself exhaled. And the lava it produced? Scientists have identified it as komatiite, an ancient, ultramafic lava type that hasn't erupted on Earth in over 2 billion years, because our planet has cooled too much to produce it anymore. Io's lava reaches around 1,600 degrees Celsius. Modern Earth's volcanoes top out around 1,200. Io isn't just the most volcanically active world in the solar system. It's a time machine. It is showing us what Earth's surface looked like during the Archean era, 3 billion years ago, when our planet was young and savage and barely recognizable. Studying Io is the closest we will ever get to watching early Earth erupt in real time. That's almost poetic. But what comes next is just terrifying. Let's talk about Io's atmosphere, because it has one, barely. And what it does every single day is one of the most extreme atmospheric behaviors ever documented anywhere. Every 42 hours, Io completes one orbit around Jupiter. During that orbit, it passes through Jupiter's shadow for about 2 hours. Sunlight disappears, temperature drops, and roughly 80% of Io's entire atmosphere freezes solid and falls to the ground as frost. The atmosphere doesn't thin out, it doesn't weaken, it collapses, it ceases to exist. Then sunlight returns. The frost sublimates directly back into gas, and the atmosphere rebuilds itself from the ground up, from scratch, within hours. Scientists described this as a constant state of collapse and repair. Sunlight itself controls whether Io has an atmosphere or not. Every single day, the atmosphere dies. Every single day, it comes back to life. There is no other body in the solar system where this happens. But here's what makes Io truly unlike anything else we know. It's not just a moon. It's a component in a planetary electrical circuit. As Io orbits through Jupiter's magnetic field, the motion generates electrical current. This current flows from Io's surface along magnetic field lines, all the way to Jupiter's north and south poles. The channel is called the Io flux tube. It carries 5 million amps at 400 volts. That produces 2 trillion watts of power, continuously. That current slams into Jupiter's upper atmosphere and creates permanent glowing auroral footprints, bright spots in Jupiter's northern lights that move in perfect sync with wherever Io is in its orbit. You can actually track Io's position just by watching Jupiter's auroras. Amateur astronomers with backyard radio telescopes have picked up the radio emissions from this connection, signals that get louder and quieter depending on exactly where Io sits in its orbit. A moon, broadcasting its own position through radio waves like a beacon. And now we've arrived at the last point, the one I promised you at the beginning. And it is the one that, every time I think about it, makes Io feel less like a moon and more like a tragedy. All of that volcanic activity, all those eruptions, all that ejected material, it doesn't just drift off into space harmlessly. The sulfur and oxygen that Io blasts into space gets ionized by Jupiter's radiation. It becomes charged plasma, and it forms a massive ring around Jupiter called the Io Plasma Torus, a donut of superheated gas with a temperature of about 1 million degrees Celsius. Jupiter's magnetic field grabs those ionized particles and accelerates them to a significant fraction of the speed of light. And then, because Io's orbit carries it directly through this region, Io flies back through its own debris. Every single orbit. It passes through the plasma torus it created, through the high-speed particle field it generated, through the radiation environment it built with its own eruptions. The radiation environment around Io is so extreme that it makes Chernobyl look like a tanning salon. Spacecraft visiting Io have their electronics fried. The radiation is that intense, and Io created it. Io is being irradiated by its own volcanic output, eaten alive by the very destruction it produces. Trapped in an orbit it can never leave, around a planet that will never stop squeezing it. Bathed in radiation it will never stop generating. It is, in the most literal sense, a world destroying itself in slow motion. Forever. So let's bring this back together, because we covered a lot, and I want you to feel the full weight of what Io actually is. The ground moves 100 meters up and down like clockwork. The mountains aren't volcanic. They're being squeezed out of the crust by the weight of lava above them. There's a lava lake larger than Lake Ontario that overturns on a predictable schedule. The volcanoes are in the wrong place, and the best explanation just got thrown out. A single 2022 eruption was 5 times more powerful than Mount St. Helens. The lava matches what early Earth looked like 3 billion years ago. The atmosphere collapses and rebuilds every 42 hours. Io generates 2 trillion watts of electricity and broadcasts its position through radio waves. And it is being destroyed by its own radiation, trapped in a permanent cycle of creation and annihilation. Io isn't just the most volcanic moon in the solar system. It's the most extreme geological object we've ever found. A world being torn apart in real time, powered by gravity, running on electricity, and slowly consuming itself. And it's right there in our solar system, orbiting a planet you can see with your naked eye on a clear night. If this video changed the way you think about Io, drop a comment below. Tell me which fact hit hardest. Was it the ground heaving 100 meters? The atmosphere dying every day? The 2 trillion watts? I read every comment, and I genuinely want to know. If you're enjoying this, do me a favor. Hit that like button right now. It genuinely helps this channel reach more people